Let's take a look at these examples. This time we have quadratic trinomials. Most of the time, when you are going to factorize quadratic trinomials, your answer is going to be expressed in terms of product of two binomials. How to find factors of quadratic trinomials? Let's take a look. We said we're supposed to get product of two binomials. First, you have to always look at the leading coefficient. Remember, a leading coefficient is the integer which is next to the variable with the highest exponent. In this case is a. If my leading coefficient is 1, the leading coefficients of my binomials are going to be also 1. I write them as a dash 1 because they are invisible. That's why I'm going to write a over here and I over here. Why? Because the product of these two terms, product, supposed to give me the first term of my quadratic trinomial. Next, these two terms, which I'm going to write over here, multiply by each other, supposed to give me the third term of my quadratic trinomial. And these two terms added to each other supposed to give me the middle term. Okay, so let's take a look what we can write over here. But before I'm going to find the values, I have to look what signs I'm supposed to have. Anytime you have positive sign next to the third term means that the signs of my factors are going to be the same. If I have positive sign next to the second term and positive sign next to the third term means signs of my factors are going to be positive. Next, what numbers multiplied together are going to give me 15? Someone can say 1 times 15. 1 times 15 is equal 15. But the question is, 1 plus 15 is going to give me 8? No. So this is the wrong pair of numbers. Now let's check another ones. Let's say I have 3 times 5. 3 times 5 equals 15. Okay, so it works. 3 plus 5 gives me 8. So this is the right pair of numbers which I'm supposed to write over here. 3 and 5. So I can say this is the solution to my problem. I have a plus 3 times a plus 5. If you want to verify your answer, you're supposed to just use the FOIL method and simply multiply every single term from the first parenthesis by the second. A times a gives me a squared. A times 5 gives me 5a. 3 times a gives me 3a. 3 times 5 gives me 15. If you are going to combine the like terms, you'll get a squared plus 8a plus 15. So take a look. This expression is exactly this expression. So this is the solution to my problem. Let's take a look at this example. Again, we have to write the parentheses first. Look at the leading coefficient. Leading coefficient is invisible 1. That's why I'm going to write just simply x as a leading coefficient of my binomials. Why? Because product of these two terms supposed to give me the first term of my trinomial. X times x gives me x squared. Next, I have to look at the sign which is next to the third term. It's positive. Positive sign is telling me that the signs of my factors are going to be the same. The positive sign next to the second term is telling me that these two signs are going to be positive. Why? Because when I have positive and positive, these two signs have to be positive. Next, what am I supposed to write over here? We said that these two terms multiplied by each other supposed to give me 6. And these two terms added to each other supposed to give me 5. Okay, someone can say 1 times 6 is equal 6. Okay, this is true. But 1 plus 6 gives me 7. I'm supposed to get 5. So this is wrong pair of numbers. Let's check another one. I have 2 times 3. 2 times 3 is equal 6. Okay, it works. 2 plus 3 gives me 5. Oh, so it works perfect. So that's why the numbers which I'm supposed to write over here are 2 and 3. This is the solution to my problem. But let's verify our answer. We said we have x plus 2 times x plus 3. We are going to apply the FOIL rule. X times x gives me x squared. X times 3 is positive 3x. 2 times x is 2x. 2 times 3 is 6. So I have x squared plus 5x plus 6. As you can see, this trinomial is exactly the same as an original trinomial. So this is the solution to my problem.